I have some slides from previous years, and I need to bring up your project into my active memory, but you can do it here. Okay. So before running any codes, and I think these materials will be of a curiosity to everyone, but if you are not Eva and you know what to do for your project, go ahead. This bit of entertainment that I will offer to everyone right now is secondary compared to just getting progress on your project. So Melody was suggested to contact Dr. Khan. Eva, if you have problems with the project, not general, try to contact Braden Wade. So he was undergrad here like 5 years ago, and now he's at suburb of New York, University of Rochester, and he did some calculations towards the project that we can borrow and use. Okay, so I'll try my best, but his help will be useful. So here is what Braden computed for one of this, how you call them, enzymatic activity. So I do not know, is it something that you believe in, if it is still research valuable, but there are some parameters. If you want to reparameterize your project and do something different, it may take too long. So you are free person in a free country, but it's recommended to use this one. So what is going on in here? So this is of initial molecular dynamics that you do not need to. You use outcome of this calculations only an input to your method code. But here the initial molecular dynamics differs from did you hear about molecular dynamics before? Molecular dynamics? Dynamics of molecules. Right? No one? Molecular dynamics?
Specifically.
Don't you maybe school high school teachers didn't maybe
like kinetics or
if you like if thermodynamics classes of lower maybe scale or any level, one makes its box, fills it with like balls, a computer, make them collide and extract temperature and pressure.
Okay, so is it like when you're learning about the different phases of matter, it's like the little like simulation where it's got all of these atoms are all these molecules are super close together, so this is solid, and they're like bigger than.
Right. You may have seen, you should have seen the simulations. Right? Boxes, you set up temperature, they start moving, providing each like ball, each atom moves based on using equation function they provide, and one has a mechanistic justification for idea of the X ball. Even if you haven't seen it, you may be reading, right? Like molecules are moving and they collision walls create pressure. The bigger they move, higher momentum, higher charge. So there are vast majority of the codes in our dynamics when you draw the molecule or group molecules in large dynamics and see how things changing over time, and it is often used in biochemistry, like docking of proteins, folding of proteins. So it is like a great paper, great answering, great puzzles of the nature, but from methodological point of view, it's born and cheap because in the regular supposed to not give any negative evaluations on the camera. For scale molecular dynamics, it's very cost efficient. And it doesn't but there is some additional effect that you can say in about it. The force molecular dynamics does have bounds defined. If one sets up bounds against a certain pair of atoms, it will stay through the whole dynamics. But if you are a chemist, scientist who studies bond breaking and formation, it is not your choice because you need to break bond molecules. With broken bonds and form them. Then, force fields, Newton and modern dynamics need unusual events where there are no ribbon thrown force, there are no assigned force. There are only positions of ions, and then electronic clouds explicitly and based on formation of this point and point of the molecular orbitals, atoms are glued together or they're free to each other. It's also a little advertisement to again 476 that it in the spring of this year is kind of overall. But yes, if there are more than 5 people, I can like teach people this person that so if you do reactions, you need this opportunity for following. On another hand, when you are trying to present to each of us this advanced thing that I never can understand, enzymatic protein, blah blah blah. But in the core there is a protein, iron protein, and there is a reaction in the product that change while contacting with this iron, right? So in this example, in this particular reaction, reactant is like originally iron is coordinated to an O, which if one goes into liquidity, it's something that makes heart healthier or make brains more merrier. It's not laughing gas. Right? And here it is attacked by hydroxyl group OH from sodium. So if an O and OH would collide in water or in a vacuum, there is a chance that they will not notice each other, or they will prefer other friends to set up projects. But since an O is already attached to the iron, it absorbs, it forms one with oxygen from this OH group much heavier. So you should anything tell about this area of weight because it's not my profession. Just tell me what I see. So this is a chemical reaction of forming, how would you call it this? One nitrogen oxide, one hydrogen, something like nitrous acid, they give it a nitric acid, HNO3, there is HNO2, HNO2. So,
Nitrous acid.
you guys had freshman chemistry, you know better than I. I never had freshman chemistry, so I'm not good at being able to explain it. So, formation of nitrous acid from nitrogen oxide and hydroxide. And it is catalyzed by the iron specter from this porphyrin that is embedded into enzyme. Right? If this will serve as a seed of a big successful research, right? Maybe in the future we'll apply it to another reaction, which are more and more relevant. Okay, this iron before reaction has how many coordinations? You guys have taken in already, right?
Just red.
I'm
Red's in it right now.
So if I freeze it at the beginning, the iron, how many nitrogens does it neighbor?
6.
Okay.
Or
So 4 in the square planner, but
yeah.
there is some crazy functional group that creates this coordination and is coordinated with one of the reactors. So it's near what the keep. And you guys as professional chemists should know it better, but maybe this coordination of nitrogen oxide with iron pools filtering cloud make it less stable and easily acceptable to responsible to another reactor. And therefore, this temporarily bond serves to lower the activation energy of activation barrier for the reaction. Now, if you want to look on this reaction mechanical, we can see two things. One, that hydroxyl, I should humbly focus on myself. Just for 1 second. Nope. So the hydroxyl group approaches nitrogen. So this distance changes and then maybe elongates or oscillates. And at the same time, what else happened? As soon as teach me maybe nitrous polycystic.
I think that would be nitrous.
Nitrous.
It's 22.
Okay, so as soon as nitrous acid forms, the bonds between oxygen and nitrogen becomes much stronger than coordination bonds to iron and iron releases. So overall molecule increases and distance from iron to nitrogen increases, right? So if you want to think about this reaction, you may want to we need to track at least 2 degrees of freedom. Although this molecule has like around less than 100 atoms and 3M will be like 300 degrees of freedom. We need at least 2. That are labeled and changing over time. Distance between oxygen and nitrogen, distance between iron and nitrogen. Right? So as professional chemists, you are well aware of the concept of activation barrier. And how do you get rate of reaction based on activation energy? Name of Swedish guy. You should know. Swedish guy.
Sure, how it.
Yes, M+1. Okay. You recognize it? As she speaks?
What is?
No.
No.
Yeah.
Even dumb physicists could never chemistry know it.
I don't remember.
Title of review.
Acid and base.
Google the right equation. Google our K equals A E to the negative. E
Oh,
over
yes,
RT.
yes,
Yes?
yes.
You recognize it? So I ran you for.
Okay,
Oh,
all right,
okay,
understood.
I got it now. No longer dumb.
That sounds Swedish.
Huh?
You say he was,
Oh, just look at your Wikipedia for this last for his last name.
oh, it just does.
Okay.
His name's Fonte.
Now it does.
Yeah, Google. As a Swedish scientist,
That's
Svante August Sorenius was a Swedish scientist. That's the first thing on his Wikipedia. Originally a physicist, but often referred to as a chemist.
The heroes. Icons.
okay, yeah, so activation energy is part of that.
Right. And when you speak about reactions, you draw this. What will they do together? Reactant, transition, product. Right? So the total energy of your reaction box, a mixture of whatever happens inside.
Sorry, I pressed a button.
Right?
Bad, but
In Wicks Castle? He was born in Wicks Castle, Sweden. Sweden.
died in Stockholm.
Oh, his children's names are Olaf and, oh, it's cute, and Annalisa or Annalisa, but Olaf is really, but I was on it.
Awesome.
I don't know, is there connection, you guys here in the States have connection to Swedish culture in general?
Yeah, my family makes Swedish meatballs every year.
Okay. In Proverbs, so even there was one of the relatively modern children's writers was considered as very, very popular. So every kid knows. So there is on a global scale in Sweden itself, she is not known and not famous. So Astrid Lindgren. Lindgren? So it's like several consonants together, and she wrote it's a kids novel. Oh,
Lindgren?
okay. And there is a kids novel, Carlson, who lives on the roof.
Right here.
Did you? No one read it?
Know that.
No, I don't. I think I
It's
found
not
out your style.
I don't know that man. Could be long stocking.
I definitely recognize that art style.
Okay, I'm going too far from the subject. But it was really popular and every kid knows that there's a popular cartoon. It's a character who exists only in the dream of a 7-year-old kid. And the 7-year-old kid tries to convince parents that this character exists. And he is a little fat man with a propeller on the back and a button on the belly. He pushes the button, starts flying, and makes jokes to kids. Very, very far from the subject. Okay, reaction product and the beverage. So the total energy of this reaction box as function of a reaction coordinate for time, right? So suppose you are the big boss, the director of computational research. So you don't need to know how things work, but you need to give right orders and reward people who do the job. Right? So to study this reaction, one needs several snapshots of this molecular dynamics, right? And when at each time one needs value of nitrogen oxygen distance, value of nitrogen iron distance, and total energy of this molecule. We can imagine that as reaction goes by, the total energy will probably increase and then decrease if you begin a very small and if you expect it to be the normal system. Right?
Yes.
And parents tell in the story about Carlson, parents tell to him, "You are telling us about a mythical creature. He never exists." Okay, so here are the data. So distance from yeah, maybe there will be not everything is displayed here, but at least in the table. So there is a total energy, right? And it is now 2 volts, and it has a big negative value because there are many, and when you bring all atoms together, they do not explode, they rise equal together, the energy will be negative. There is stabilization power. Some will not allow us to light. You know that. Positive energy means explosion, negative energy means stable. Absolutely. Okay, so generally it is stable, but little pieces can go apart. And here are, yeah, this is total energy. By some reason, it's not a barrier, it's mostly deep, maybe when molecule deep form and stays on the barrier. So it's a little unusual. So it goes downstream in energy and then climbs up to the bar, maybe then goes down as much as you include in simulation. And here, the other two things that we do, distance between oxygen and nitrogen, distance between iron and nitrogen. So this information from the breaking would be input parameters for your model. Okay. If one looks on this here, if one plots it as a parametric plot, so distance between iron and nitrogen, and this between oxygen and nitrogen simultaneously in a two-dimensional plot. We start in the situation where the distance between iron and nitrogen is small, like 1.6. And as time passes by, later on, the nitrogen departs from iron, from catalytic sample. We look on the distance between oxygen and nitrogen. Originally, it is far, much longer than the bond distance. And as time passes by, it moves together and then slightly elongate, but then stabilizes at the bond distance. And all the thing is connected to the energy. So one thing that is possible to do for these parameters is to I just don't know how to combine all sorts in one sentence or even more than one. If you would perform as a director of several hundred subordinates, each of them is current computers, we would probably order them to explore different initial conditions for this initial reaction and reconstruct potentially circuit. So when you are, never had an option to be another things, but when you are in the undergraduate case class, you typically draw one reaction coordinate and then reacting transition state and product energy, right? But here the reaction is substantially two-dimensional. If one there is no way to select one reaction coordinate, one needs to simultaneously modify at least these two parameters. And it is what we learned almost a dozen years ago. This not dozen, yes, 7 years ago.
Dr. Gerard's,
Yes. Oh,
On that.
yeah, she's in your well,
Oh, I-
look at your boss. Okay, so he was taking the same class just branded for graduate students, and there was an attempt to parameterize it as a single reaction coordinate, and everything failed. It was very unusual. But it was like wisdom of years to that this reaction needs at least two coordinates. So if one wants to describe two-dimensional reaction, one needs like surface energy as function of two coordinates. Right? So for transmission, well, the problem is so much easier because if the potential energy serve potential energy in one and another direction adjust harmonic oscillators, you get it. For you have only one trajectory, but we can make an assumption that along this trajectory we know in nearby maybe you will have some energy will be less efficient. So we can make a tweak and do it like range in space. Range along this path, where along this path the energy will be less, and everywhere away to be higher. So this model is not data to go along this trajectory. And then, so this is this range. Blue means negative, orange means positive. And then one can first try classical and dashed line is the trajectory extracted from aviation algorithm. So if one tries to reproduce different trajectories, we need different initial conditions. This artificial potential in the surface, one can start at slightly different initial position, with slightly different initial moment, and see what would happen, how the system of this coupled 2 degrees of freedom will evolve in this potential. And ideally, we would expect that it would reproduce this trajectory, but it may do something different. So do some strange behavior, which here it means neutralization will form, but will not be the catalytic center. We just draw it around. Okay, but this is only classical. So we do classical dynamics based on initial parameterized potential. Now, if you take this potential, plug it into wave packet code, and then run for the wave packet dynamics. So the things will look more interesting and more dramatically different compared to what we all did together. There are some similarities and differences compared to what we saw in your other projects and what we did in the past. So before we had only one reaction coordinate, or one independent coordinate. And then if wave packet was moving, I think it was Fred who was plotting real and imaginary parts of the wave function.
Yes.
Right? So the higher the momentum, the denser the fringes. But the fringes were along one coordinate. Now we do have the dynamics in 2 dimensions, which means the fringes are going everywhere in each direction. So if we go from the slope, and we start. So this is a test case when one places initial Gaussian wave packet somewhere in the middle, instead of at the reference side, just a little bit. So this concentric circles means that in the center it height, it's like geodetical lines on the maps. And as we go away from the center, it goes slower and lower. So the product of 2 Gaussian, right? As we allow this wave packet to move according to evolutionary Fourier and Schrödinger equation, so we see that center may be in the same place, and it is only real part, similar to what Fred was doing. But you see, because there is a potential, because there is a slope, incline, it picks up, it feels the force and it picks up momentum. And originally we started with a wave packet that does not have any fringes. And as time passes by, we do have more and more fringes developing. It means it slowly starts moving either this direction or this one. I still don't know how to read the direction, but forward and backward, but definitely along this line. So the line along which positive and negative change each other, it means where wave packet moves, it picks up the velocity. And then one can see how things are changing over time. So the collective work of writing wave if I pronounce correctly, approximately.
Yeah.
Can we get care of this situation? So you get pose in the France, but there is still not a full picture, even if you do everything. And there are several open questions. So the question can be formulated as follows, and it was, I believe I was giving it as a steps towards completion of the project. So what I see you are going to find looks at board.
Well, I'm just trying to follow.
Me too. So once it start this different momentum, right? And the higher the momentum, the higher the temperature. And looks for the probability of the wave packet disappearing from the reactant and appearing in the product area. And if this can be reported as function of temperature or of initial momentum, it will be more than enough for the product. So find reaction rate as function of initial momentum. This simple problem that would be nothing to do in one dimension formulation is already a big challenge. So maybe as on the way to trying to address this question, you'll find some difficulties and you can report what they are and how you were trying to overcome them. This all will be of long scientific development, and it will be even if results are not very encouraging, not very really experiment, it still will be of interest and still potentially published if people put enough effort into writing it up in form of a mention. Okay, so I will show a few other slides that will of interest to more the audience. That you can explore the codes are running, and then let's go by and so hope you guys are not falling asleep yet. Not yet. So here is the little thing that we did together last time, right? You remember this. So if we want to model in one dimension, we want to model a single atom that attracts wave packet, we need to mimic attractive potential, but not exactly Coulomb, because Coulomb potential would work only for 3 dimensions. If it is 1 dimensional, it needs to be modified. And I believe it is what ELSA has, like summation of several atomic dips, right? Symbolizing atoms in different positions, right? And Fred has similar thing, right? Positive ions attract an electron. Originally, atoms are separated by certain distance or bond distances, but uniquely for Fred's project, if the electron attract ions by Coulomb force, the interatomic distances may change, right? And at the same time, if they change, they start attracting electron in a different way, and overall wave packet localizes and changes its shape, right?
Yeah.
No smiles this year. No laughter this year. No one does solar. So. Oh, okay. I think I got a credit for my drawing. Oh, thank you. So this would make sense if any of us would select to do solar cells. We do not, but generally, well, I'll already tell since right there. In the project by L, the electron goes from one material to another because of applied electricity, because of implying also potential. But and it goes like any resistance or conductor or interface of materials when we apply power. Right? But there is a way to drive electrons from one material to another by photoexciting it through light. Right? And it is a major principle of photovoltaic solar cells. So maybe next year someone would show like this one. Okay.
Once we get Wyatt to come present on it.
Right?
Yeah, have Wyatt come present. Guest speaker. Present on solar cells?
Does he do solar cell for his, Drew project?
I think so, actually. Yeah, I think he is the one that works on solar cells. I don't know what Spencer works on.
I think he was, he was doing it, for his rotation project. With MATLAB,
With you.
mhm.
Uh-huh.
And I think we will have recordings of him presenting.
I'll have to go find them. Are they on YouTube?
Yep.
Use them as blackmail.
So, in this sense, solar cells and, electrochemistry that they are is doing are similar. So there are two materials, and one looks for probability for electron going from one material to another one. Just the reason of motion. One is slow, another is promotion from ground to exact state. Now, a little thing that could be useful for several of us. Maybe for all of us. Maybe for all of us except Sam. Or maybe for Sam too. So, I'm going to provide a very oversimplified background for the thing that you were plotting and looking at and analyzing. So remember, when you run the original template of this wave packet code, it draws probability of reactant occupation and probability of product occupation. One line goes down, another goes up. Other blue. Probability of reactant occupation, probability of product occupation is the main observable that you are going to compute. The blue corresponding to the line. Do you remember?
I think so. I have my notes.
Notes, I'm not sure about it. Memory is stronger. Does
Mine's
anyone?
not. I don't remember.
Mine is very well. But does anyone remember this probability?
Yeah, or if they like cross. If the two lines cross, then it will. If the two lines describing what is it, the reactant and product probabilities, if they cross, then the reaction will proceed. Like, yeah, I can't remember like what changes whether or not they cross.
Okay.
But it's to like figure out like the activation. Okay.
Okay, let's go to understands the creates here.
I trust him. I don't know if I really understand.
Okay, then let's formulate what you understand.
I don't even know if you just was saying something about if two things overlap, then.
Direction will, yeah,
So which is
Probability of something.
It's not this graph, but it kind of looks like this graph where like you have these two lines that are starting here and here.
Isn't
And if they cross, yeah,
we'll run the code right now. Yes. Ideally, maybe I would ask you to share to do, or at least we can scroll up and run, we can run and show to your. Yeah, let it run, and then when it is done, there will be. Yes, when it is done. So it will pop up several additional videos, and in the last of them, you show the thing that Fred and I were agreeing on and ever placed under doubt.
I don't know.
Doesn't really
We should that too.
It's working. It's working.
It-
It's going.
I know we may delay overall progress on practical things, but I think understanding is ways of conversation. Are you writing anything right now, or just following this prayer for the future? I will do it right away.
Dimitri, is this right? That can't be right. This is not.
No, it's perfect. It's
It
perfect.
has
Okay.
What would you want to see?
And now let's, so that we see what's now. Yes. So we do fair share of errors. Elsa did computation and now Eva will do analysis. So Eva, please look and say. And what you like and do not like.
Brother champion.
What do you mean that I like and what I don't like?
Just-
We have probability on the y-axis and time on the x.
Okay.
And as time increases, there's kind of two lines.
And I think they're overlapping.
Yeah.
They're not yet overlapping.
There's a couple things going on here.
But they are minor, be useful, negligible.
Oh, that doesn't.
Well, it can go into supplemental material, but not as a major effect. So, maybe we can ask Elsa to run the code once again with different value of the electric field. Like increase electric field 10 times. And everyone is welcome to stop by and watch or
Yeah,
or we can ask Elsa to go into Zoom and get the big screen.
I think that would be really-
Where? Oh, that's right, because that's the one that we talked about.
Same thing.
And now we gotta wait for it again. I have a clear mind of what I'm going to. Mind is clear. My brain is huge and.
And maybe if Elsa declines to project on the big screen, we can all come here.
Yeah,
And
come
watch.
gather, come gather, everybody.
You can only the secret from those who watch the point, but at least.
That's fine. Oh. It's frozen. Oh. Oh, no. We do not, hold on, we have to redo it. Where is it? Oh, that's it. No.
Let's fix it. Let's do Control C in the command line.
Yeah, what is that? Yeah, beats. Which beats are playing?
Let me.
Control C. No, Control C. No, we have all, let's, what did you do?
The electric.
There it goes. Now don't touch it.
Yeah.
No one breathe. Yeah, don't breathe that.
It's you. You're
I
the
have
problem.
beats inside myself.
You're the problem.
Please.
I was reading a story. When a person had was able to receive broadcast radio signal by the feeling in the because it has like semiconductor and
All of those, sure.
and the advisor of Eva is
Captain Rogers.
able to receive NDSU broadcast radio on his spectrum.
Oh,
Really? That's so funny.
I'll ask him, when he was given a box like for incoming high school students, his parents, they were coming and then we were doing tools in the lab, and in one of the apparatus, Dr. Rogers has the tin box for fresh air use, like outlets, whatever. Although it's.
Oh,
And everyone was asking, what's that? And he goes like, I need to protect.
I don't really know what it's for, but I have also asked them to, like, why it's there instead.
It makes it screens the equipment from radio waves or local radio station. Otherwise, just wires in the apparatus pick signal and one can hear it.
I have another story about the same type of thing. So my mom has a dental lab across the street from a radio station. And the metal hinge in her door, the employee door to the building, will pick up the radio waves from the radio station across the street. And so there have been employees that are there like late at night by themselves and they can hear talking from like one side of the building. Because the door, like the door frame, the metal door frame is picking up radio waves and is like playing sound from it.
That's cool. That's cool. So we have an evening of fun stories. No, we get better than climate. I have another story on this project. In like early 1910, radio stations were less lower quality and they need to give very high power to transmit any signal. And they had like gigawatts. And radio waves are generated and received through the LC circuit that we have. So the people in the vicinity of big radio station, they didn't have any engineering education, but they picked it up naturally. If one creates like a capacitor and induction, connects them to electric lamp. No, the lamp will flash complete. So they so and then the radio broadcast company was noticing that someone is stealing their energy and the power of the radio signal is much lower than expected to major customers, but the whole village nearby was having free electricity.
That's so funny.
So you increase the voltage and the incline of the lines increase, right? So at the end of the direction, instead of 3%, it's not 10%. So what are these lines? Yeah, maybe do yeah. Remove all of those, otherwise you can.
Whoa.
Anyone else? I can find her too.
I love that story. It's creepy and I've heard it for myself too. Like it's just coming from the door.
Speaking of radio waves, walkie-talkies.
So gotta get walkie talkies. Petrie, you wanna walkie talkie?
Yeah, we're letting them talk.
Petrie.
You know, I'm gonna look.
We're gonna get one for.
Yeah,
Kilo coming.
yeah, we have to have a little lane. Don't know when you can hear it.
Yeah.
Brush it
So we're
right
gonna
now.
get one for Sets Lab and Kent's Lab and, Getting's Lab. Zoe wants one too.
Yeah, and you can have one. So
I want one.
yeah, you can have one.
Yeah,
It's like different.
Military.
Oh, nice. Well, that's not a spotlight. That is a good point.
Whoa.
These are.
So wacky lines.
Okay, that looks really wild now, actually. There's all kinds of different shapes occurring.
But you see the direction goes very vividly. And then there are some numerical errors that originally they crossed. So it was,
Yeah, they cross.
correct. So probability of product became higher than probability of reaction. So yield of reaction more than 50%.
Yield of reaction more than 50%.
So why is it yield higher than 50%?
Because she drove while with this very strong.
So it will make a product. Favorite product.
Based off of that graph? Or is it just like based off of the numbers that you input, you know that it's.
So if Elsa would be so kind She's waiting, but after she's done,
Oh, God, now everybody's gonna be waiting for me. No, it's gonna be slow.
silent. Oh, there we go. Let's do it then. When you are-
Silent fire. It's called selections from frogs. And there's selections from frogs number 1 and selections from frogs. number two.
Frogs?
Yeah. And they,
Just throw it in the back.
okay, so at the beginning of each frog, there's a poem, and the poem is the lyrics to the song, and then both type these. And the first one is called Day Darkened, and it's,
Continue this actually.
it's basically about, so the frogs. As it gets closer to night, the frogs start croaking,
Yes.
and they call them old grumblers.
Oh,
And in frogs two, it's talking about how it's a very silent frog, it's called the old silent frog. And then all of a sudden, a frog turns into a frog, splash. And we don't stop, we don't, there was a smile, actually.
We need to join this reciting.
And then after all the frogs start to pass, what time? Which is, it's on the corner of 12. So it's like, wow, that's all you. No, but it's right by it. Okay. So like, you know that stoplight when you're on 10th and you need to go towards like 50 down or something?
Yes.
It's that church on the.
Okay, yeah,
6 feet in.
I love it. 6 p.m.
Chances that some of us or all of us will join are dramatically reduced.
Yes.
So, what do we can we ask? Oh, Kevin is busy, maybe 7 and what?
What the heck is this?
Can you look on the greenish figure and tell how does it come? It would localize more to the left. More to the right.
I mean, it's in comparison to what the red.
No, in comparison to what it was at the beginning. At the beginning, it was a we expected created at the left side. And as time passes by, it progresses towards right.
So, yeah, of course, you're right.
So I'm not going to ask anything to Brad because he already got a pass on this question.
Congratulations.
But some of us were down in this.
Down on that.
Right.
Yeah, I remember somebody slammed it.
Now,
Thank you, I just was a little uncertain about what you were talking about, Fred.
That's not how I-
but let's make connection between this and this part.
Yes.
Maybe and this.
That one looks like it has its fangs, like.
Ooh, that's right. But I'm looking for the. This, yeah, the purple line. Here and green line.
I like it.
What did you say? The green line here.
That's what everybody's saying, is that 6 p.m. We're all going. We'll up at 5:30.
Not you just do that.
So
You're gonna have to drive over to Mormon.
so
Yes, we treat it.
as time goes by, the way packet moves to the left and right.
Yes.
Okay? And
The
this,
left and the right.
and this line shows what each, how much the way packet moves from left to right.
What? This is showing how much it's moving?
X-axis is time.
Yeah.
Okay, I think.
What are the axes on this graph?
Position.
Okay.
So you're masters of space and time. So I think I did intrigue everyone sufficiently. Let me go back to thing on the screen, and maybe everyone will accept. Well, you accept it more than reject.
Yes.
Maybe as for us, you now. Yeah.
This is when it moves from the most
Right. So, I know I'm terribly delaying all our practical progress, but I think we are laying most solid foundation to what we all are doing. So, how do you like my drawing there? Oh, thank you. So, here is the wave packet, which may be like nice Gaussian wave packet where you can chop on things and have more fringes. But it is defined from like 0 to like size of the box, right? And then, so the integral under this curve must be equal to, yes, correct, because it is normalized wave function. Now, if we artificially chop our space on two sides, right in the middle, and then you perform integration from 0 only to the middle, and then from the middle to the end. So we will do from 0 to like middle, and from middle to infinity, or to the last point.
Yeah.
You can call it probability at the left side and probability at the right. If we add them together, the result will be 1. Right?
Yes.
Thank you. I'm so happy that you agree with this. But the proportion between them will be different at each point of time. When we create wave packet at the left, it will be 100% P sub L. And P sub R at time 0 will be 0. Right? As time passes by, PL will decrease and PR will increase. Okay? Now let's roll back half an hour ago and please repeat your speech, and we'll check how enthusiastically everyone accepted it.
I don't know, I mean, when the probability of the lines describing the, products reactants, like Nick Cross, like that's when we get more products. Reactants, because there's enough like energy to drive that reaction. Did I say it right?
So if the probability of reactant decreases to 50% or lower, and since reactant class product will be 1, the probability of the product will be more than. Which means this, if you plot these two lines simultaneously, they will intersect. And it is a visual criterion that spread over all of us. So if product and reactant lines intersect, it means reaction is efficient. Now you have accepted most of the.
Yes.
Thank you much. Fred, you're promoted to TA in physical chemistry.
Oh my God.
Okay.
You're gonna hate me.
Oh.
So, and if we will be old style obsolete students of previous years, then all of us would be doing only reaction as function of time for one dimension, but each of you is unique. So Elsa does not just reaction driven by heat, but reaction driven by electricity, right? Eva does reaction driven by heat, but in 2 dimensions. Really impressive, scary, and worse of admiring.
Yeah, admire me, would you?
Finals.
Yeah.
Melody does one-dimensional reaction, but in different electronic states. expand Voltron to 11, even if there are no reactions yet. In this project, it is something really unique.
It is pretty interesting.
Fred is, for the first time in 12 years of this course being offered, he allows atoms and electrons to move at the same time.
Wow, Fred, groundbreaking.
Oh.
And Patricia, ever has two dimensions, and in her project, one of the dimensions will be understood as laser field. So your project is a unique and more advanced than this consideration, but we still can make connection to the definition. We can make definition, define what is reacting, what is product, and explore. So we need an observable that we report. We all get nice multidimensional figures with fringes, with white packets, but if you want to sell it to our experimental collaborators, or if you're experimentals yourself, you want to get any benefits, like what is the use of nice figuring? They're just decoration, what way? We need an observable that can be measured on real experiment. And the use of the reaction is something that one can correlate with actual true life. So converting our wave packet dynamics into this probability of reacting the product is really beneficial thing, not because it is so complicated or it is so beautiful, but because it makes a bridge, it makes connection to real life. Okay. So here is what Fred was teaching to us. The summation is 1. They are expecting to intersect if reaction is efficient. And for sometimes they behave strangely. They go up with oscillation, sometimes they go down, but it is a uniqueness of each of the projects. Now, I am going. Emma, is it enough?
I'll do that.
Okay. So I'm going to say something that literally the diagram that I'm showing is not used by anyone this year. But by what it is related to Fred, but by there is the most best. Okay, I have clear mind. I'm just a little delayed in speaking.
I have neither.
Hmm?
I have neither a clear mind or a train in speaking, so.
So most direct connection of this diagram and what I'm going to speak is to melody and to our last didactic academic question. So before we go to peer review of manuscripts and presentations, I'm going to offer Francois principle. So this diagram relates to the same effect that Fred is going to describe, but from different angles. So there is the background of the processes that Melody and Fred are describing have some similarities, although they're different. And when the pictures do not completely look different from what Fred will do. So first, I will speak as if I will be privately talking to Fred. Then I will speak as if I privately talk to Melody, and then I will try to summarize for you. So when Fred is doing his project, one creates the electronic state with a certain interatomic distance. And as time passes by, interatomic distance in 1 degree it decreases, in 1 degree, but it changes and arrives to equilibrium. At the same time, the electronic wave function changes. But this would show how the energy and interatomic distance changes simultaneously. Okay? And although in your project you are not exciting, but if one would track what would be the energy of the excited state, it would probably change as well if we modify interatomic distance. Okay. Now I'm speaking as if I would be speaking in private to Melody about her project. So the wave packet from the ground state is promoted to excited state. And then the force in the ground state is zero because it is zero slope. The force in the excited state is not zero because there is slope. And if you exert a force and make wave packet to move from left to the right. Right? So how can be and potential for melody will be not harmonic, will be something more dissociated. But how can we modify our code in our one-dimensional code to accommodate for the fact that there are more than one electronic state? So if our x-axis is interatomic distance, and we do have a wave packet as function of distance, where is our second electronic state? We don't have, right? And I'm stumped in front of this problem. I don't know what to do next. So probably I need to create two wave packets, one in the ground state, another in the excited state. So I will have two arrays, psi up and psi down, or up and down electronic state. And I will have a tension V up and V down between both of them, right? Now, if I suppose I did all these things, Melody, it is your method. If you, when you're presenting, you may want to show something like this and explain what you know what you need to do. And it is very fast, very complicated. It's definitely above the undergraduate class level. So,
That means that I can legitimately publish this?
oh yes,
Oh, yes.
okay. I know that I'm wasting time on practical things, but we are laying foundation. And I apologize for this pauses. I'm just concentrating on trying to write words. So when we had only one electronic state, only one potential energy source, and we had only one Hamiltonian, and in all equations that we practiced, the Hamiltonian as an operator or as a matrix was acting on the wave function as a either function or a vector. Matrix multiplied by column vector, right? Now, if you have two potential energy surfaces and two wave functions, how do we store them? We can store them in the following way. So
Are you storing them separately or in the same? Okay.
So we need to keep their differences, but we want to optimize program that they will be bundled. So we create an array that is twice as longer than usual. So we will create an array with a portion element, x1, x2, x3 will be wave function for the ground, and then the next portion of array will be wave function for excited state. So array will be twice as long. So if in our x-axis there were n or n PTS grid points, then in U array it will be 2 n PTS. So the vectors must be affected by matrices, right? Matrices ask what? Right? If length of a vector increased twice, how much the matrix will increase? Like if I have matrix 2 by 2, oh sorry, if I have matrix, if I have a vector of 2 elements, and I want to multiply a matrix by this vector, matrix should be 2 by 2. Now, if I have a vector with 4 elements, how big the matrix should be? 4 by 4. And how bigger 4x4 is than 2x2? 4 times bigger. And if you draw, if you just draw squares, right? 4 squares of 2x2 will give 1 square 4x4. Good.
Yes.
So it is what is shown here. So vector use by function is twice as bigger, and Hamiltonian will be 4 times bigger than 2x2. So it will be formed of the blocks, right? And the blocks of this Hamiltonian will be as following. This red part will be ground state Hamiltonian, kinetic energy plus potential for the ground state. Right? The lower right will be excited state potential, kinetic energy plus excited state potential. So if there is no interaction, it will be like standalone pieces. But if there is a chance of dynamic transition between these electronic states, there should be interaction Hamiltonian between excited and ground, between ground and excited. And for the problem that Melody is going to attack, the Hamiltonian will be this complicated piece, which is at least 4 times more complicated than any other of us have attacked. So if you include potentials for ground, potential for excited, and interaction with potentials, hopefully, based on your kind email, that's a kind of send data for this potentials. He's working hard on them for last week. Okay, if we want to hate vectors and love Dirac notations, then we would write that our wave function is a superposition of ground and excited with wave function distribution curve. This rating, ground red, excited blue, should be near and dear to the brain and heart to anyone who attended the second year grade student seminar of law. So let's, I know it's very boring if one person is speaking, so maybe Patricia will tell your impression. How do you see connection between equation and what on the right and presentation?
Presentation.
I have forgotten to invite you over. One is a great student for paragraph for second year presentation and was preparing for half a year. So she started being scared in May, and she was preparing 6 months to be 15 minutes ago. It was like 2 weeks ago.
Was it good?
Yes, it was outstanding. It was.
Not at all. Dimitri?
Yes.
Good. I'm really terrified of you. It's spelled that way. Yeah.
Yes. So try to establish connection between this equation and what Lola was doing. If, at least I was able to intrigue you. So, and if this year wouldn't be so special, I would invite everyone to the computational chemistry in the spring semester, but it will be a year and a half later. So, in computer programs that you have initial, one you apply so-called Born-Oppenheimer approximation, which means one assumes that wave functions of electrons and nuclei are independent and can be set up as product. And here we do have a product of electronic state, which here is just ground or excited, and nuclear wave function, right? And in this basis, in Born-Oppenheimer basis, one can introduce coupling and make transitions between occurring states and their interaction between the alternating. You don't need to remember it, you just showing it is something really cool, advanced that really seems here for 6 months. Okay. But even if we do this advanced thing as Melody would do, we can formulate rectangle further. So we can integrate from beginning to the end of the ground thing and call it PL, although it will be not PL, it will be over the whole thing, but for ground state. And same for the extent. And then we can make wave function normalized so that the summation will still be 1, and we can analyze this problem in terms of reckoning and product probability and see the intersection of reaction having yield bigger than 50% as Fred visually guided us. Right? Okay. No, it is. In previous years, I was given this slide at the beginning of lecture 37, which is scheduled for our break. We don't have Friday. We need it Friday, right?
Yes.
But I will skip it because we discussed it right now.
Yeah,
Okay?
okay.
And then we'll go to more academics. But this, so any feedback, like, do you found this little mumbling useful for the project, or is completely false? Okay. Sam looks very skeptical. Like, I'm asking, do you find it valuable?
I'm just. You're.
He's already an expert in his field, so nothing more.
Oh, 10 years ago, there was a American sportswoman on Olympic who got silver instead of gold. And I don't remember the names, but journalists were asking, what are your impression? And instead of answering, I'm not impressed. You use a silver medal.
I can't remember that.
You know?
Yeah, vaguely. I don't remember.
You do, but it was like fun expression on the face. Okay. So now let's check if you know what to do. If you have a clear plan and you can invest the remaining time of our meeting towards your projects. You know what to do. I don't.
know that I have drafted.
Oh, just send it. No, wait. Maybe he will. Do stick to me, and then if you do implementation.
I want to give it to see if I'm asking for the right thing.
Oh, you want me to?
Why is it? 2017?
So, yes, give a name of your molecule as you gave to me. I'm just kind of reproducing because I never.
Like the full name or the abbreviation? Okay.
TPL dash
TPOL.
and maybe chemical name whatever. I will always admire professional things to name complicated questions. Okay. So even if you do not do anything, you will not lose the case. But I would recommend to run the code, screenshot figures, and put them into PowerPoint. Even if you have doubts and you may iteratively improve, let's better start. Because who knows what exams or origin of business will be as we approach the end of the semester. It's better to have something, some backup. So, same as 2 hours ago, you read that we need to cooperate first with ever. Were you able to run any codes?
It's like this one can't recognize what it's trying to load here.
Okay,
It like can't have them, and then none of them. They all are having some sort of error.
good.
Oh,
Well, I mean, it's not like good, but it's good that I know this error. And probably Sam can assist us and teach you by sharing his experience.
What now?
So, just share your experience about codes and input files in the same directory.
I still do not understand.
You do.
So it's code and input directories in the same code.
Code and input files.
Input file.
Like in your situation, input file is what was it?
Oh, sure, okay, I still haven't figured out how to run that.
But the script
Yes,
reads the input file from the directory where they both allocate.
yeah, oh, sure.
If they allocate in
If it's in the same file and you run your code, it'll use the data in which you have your file. So like I have like 5 different files and they all have varying basically distances between two like abnormalities, but because the whatever Z file is the different Z files I have are properly like distributed. So when I run like the same code, the only difference is going to be whatever's in that Z file, but it, like MATLAB and just keeps the Z file within that specific folder. So if you like group everything into like folders that are separate, so like whatever changes you make, put them into separate folders, and then MATLAB will be able to run it properly when you distinguish something. If you put the same file with just different changes in the same folder, it's not going to be able to distinguish which one you want. Does that make sense? Is that like what you're
I don't understand what you're saying, but I don't get it.
Just repeat.
He's talking about Z files and.
No, so in my case, I have a Z file. You might not use a Z file. My Z file has my code, the differences in like distance between the two things that were measured basically. Whatever your changes are that you're making to your code is what you put into separate files.
What I'm changing from what is in, from what Dimitri sent me?
Yeah. Manipulation, I don't know what you sent you. I'm assuming you sent you all the files.
He sent you 6 codes,
Yeah, put them into different files.
put them into different files.
Yeah.
I feel like they are.
No, you have to put them into different files on your computer.
Wait, just a second. Let's speak English.
Okay.
I know that foreigners shouldn't teach.
You have
Basic student, but
to separate the files into.
much better.
Each file needs its own folder.
Yes.
So you don't need to follow Sam literally, but you work with it.
Okay.
So the methods
Yes.
and the input file should be located in the same direction, in the same folder. If they're not, things will not work.
Okay.
Does that make sense?
Yeah.
So if your method is in error,
Yeah.
there's some file can trouble.
But then like this trajectory you sent me as a text file. Yes. I don't know how to,
Setting it into the same directory where we MATLAB script is.
where this one is trying to.
Correct.
Okay, I'll do that. Yes.
Okay, yeah, thank you. I'm very happy for this.
Yeah, I feel better.
After we get over this little technical things, we will cooperate on the science. Anything you like, anything you do, like, or your project is good.
Well, I'm still in the very early stages of it, you know. Haven't really
But it's.
started messing around.
But express.
I guess I'm wondering if, like, what exactly, like, what what patterns do you want me to visualize with this? Like how the like momentum or like the velocity. So I'm sending an electron through this conjugated polymer, right? And we're representing the electron with a wave packet, correct? In the code. So like the change in like potential as it passes these different atoms in the polymer that's going to change with like the speed at which the electron is moving through it.
I'm processing the information and then developing.
Okay.
Okay.
I guess my like more simplified question is just like what do you want me to show with this? Like how what do you want me to change the code and like exhibit like how it changes the
Did you have your code running?
yes, yes, it's all right here.
Another, this
one? Yeah,
So.
sorry. Like this bottom one, like that is the one more shallow one, I'm pretty sure. Yeah. Is the starting wave packet, right?
Yes, so
And then it condenses as it moves.
if you copy paste this thing and report it as part of your report as part of your figure and describe it in all details, what does it mean? It is a substantial part of the.
Okay.
Okay.
All right.
And we will get over the formats of reporting. So the question that Fred has asked, I will dedicate time in lectures and in next class, but here is the standard protocols. How to start making your reports and those. So collect as much as possible figures into PowerPoint. Do not hesitate to create like 200 figures. Later on, you will select the best one. Just like crazy. Same as in the when you do experiment instruments, you save CSV files or whatever, and then analyze and maybe use only those most successful. Okay, so collect data, and then later on, whether you understand what you don't know what, collect. And then we will combine data that are figures that are most relevant into groups, like multi-panel figures, write captions, and explain how we interpret them. So it is practical part of the work. Okay, and it's always better. Well, final written reports will be not very long, but at the time of data collection, do not be greedy. Be generous. Collect more figures than you can ever utilize. Right? Even if code works quick enough, you better collect them, and then if there is a power outage or you don't have time to run things, you better like create this PowerPoint, send it to yourself as an email safe on other computer, and then you can focus more on interpreting rather than generating data. Okay, so you can work. You can. I'm not telling that any of us should have schizophrenia, but you can work as a like. I'm not talking about you. I'm talking about myself. I'm considering myself as two persons. One person who gives orders and another who follows. Hey, you get up and do things at once, sir, and then do things because. So you need to practice both strategical thinking and completion of things. Okay?
Do my best.
I want to give another comment related to Fred's project. Okay, so Is it, are we projecting?
Sherry, I think I did it.
I'm proud of you. I'm happy for you. I will finish a comment for Fred and then get back to you. And as soon as I'm confident that Eva progresses well, I will focus on Patricia's project. Patricia, thank you for your patience. So. I'm going to do things that is an advanced subject for graduate students.
Okay.
So, but I'll try to do it as simple as possible. So convert idea behind Fred's project into language of flow chart diagrams. Okay.
Like, not on this summer. Like, that's. Like, I like that part around it. So. I was gonna make the class, so great class. I got a very on the edge day. I got an 87. This was rounded it up. Because it was 1% away. Yeah. I think for both, the distribution two and OM2, I got the exact grade I believe on the final to get it.
So we attempt to summarize Fred's project. It is a very laid back representation, may have errors and I can do it, but I believe I will communicate an idea clearly. So as an input are positions of all ions in your oligomer. Right? Then as soon as you know positions, you can generate potential and basic using potential generate Hamiltonian operator.
Okay.
As soon as you have Hamiltonian, you can find you can solve Schrödinger equation and find ground state. Select like wave function for the lowest state instead of the Hamiltonian. All clear.
Yeah.
You will be able to communicate it to the class later. Now, next step. If we do have this psi wave function, we can take probability distribution, which is wave function squared, and integrate it over dr and plug it into Coulomb force. So Q1 QI is a charge of the ion number I. This probability distribution will serve as a second charge of F. And force between them is inversely proportional to square of the distance. So this force will give force divided by m is acceleration times delta t squared over 2 will be like increment according to classical mechanics, right? How much position of given ion is changed.
Okay.
Now we change position of ions and of course it should be done for each ion. And then we look, if change in the position of ion smaller than predefined threshold, then yes, it is a success and we plot results. If not, we repeat the procedure. We reformulate potential, we solve continuum equation, find the site, it will be new site. Find fork, find increments, find new positions, and compare with predefined edge. So we repeat procedure until it's conversion. And then we find a self-consistent solution. So when repulsion between ions is compensated by their attraction to this electron. And by this procedure, as a solution, we find new interconnect distances and we find new shape of the electron wave function. Right? And this bluish figure that you show, it demonstrates how the shape of electron wave function changes along the time steps from delocalized to more localized.
Okay,
Okay.
so as it moves along and passes all these ions, its probability density becomes more narrow,
Yes.
so you have a better idea of where it is.
Yes.
Uh,
Exactly.
okay,
And this is a fact of formation of polarons.
yes,
Polaron, because this injected charge polarizes your oligomer and induces change of positions of ions.
okay.
Okay.
In what scenario would that not change the distance?
If the dielectric constant is very high and you screen any form of interaction.
Okay,
If you put it in highly polar solvent, then solvent will adjust and the molecule will not.
okay.
Okay.
So sometimes it does nothing. You
Yes.
send it, okay. All right.
But this project has in mind simplest possible conjugated oligomer like cis acetylene. But as soon as you get hand on the main principle, one can apply to any polymers, and one can do it not only by this simple method modeling, but by ab initio model and many things ever used in so.
Okay, yeah, and the number of peaks here, the number of potential peaks here, that's the number of.
Right. And you see, when ions come closer to each other, so this individual peaks superimpose and it creates a little deeper dip in the center. If you
Because
would,
it's bringing them closer
Right.
together. Yeah.
Right.
Okay, all right,
and you need to collect as much data as you need to sufficiently communicate this idea
okay,
to unbiased audience, because everyone in the class has heard you, and when there will be Dr. Rasmussen,
oh, man.
Dr. Rogers, they should accept your defense
All right,
through evidence that you provide.
I hope so. Thanks.
No, right after you run read him, without changing anything else, you need in the same directory, like run straight across. And if you purge, it will transfer information, like read him reads what you see, convert it, and then forwards it to the state. But we,
So it's always gonna be redam and then slate.
yes. Yeah. What's going on? Restarting method.
This file now. I got the file that had the movie that we were looking at. And now I'm trying to see what other ones were.
No, the one with. We don't need to restart master, but let's look on the matter of code with me and think what we can do with it. open but do not run this. So please look for P not X, P not Y in the secular angles. Okay, so one of the possible practical tasks is to rerun the code with different values of these parameters, P not X, P not Y. Create movie. The movie should store in the file, right?
Yes.
And then you can rename the file, upload to YouTube, and then create a repository of seeing a trend, like how modifying initial conditions modifies the behavior of the wave packet. Okay,
Do these have to be negative?
I believe yes, but you can explore, and I would change them just a little bit and get a hands-on experience of how change of these parameters modifies what you see on the movie. Okay. Okay. I don't. Your questions haven't expired yet.
No.
No?
My code is not wrong.
Every game, so I was reading this against NGH.
Evan, can Patricia and myself ask you which code are you running?
They're running the WP to the reaction.
Thank you. You have the similar.
Yeah, I saw you read that.
So they use also going to. What do we have separation inside?
And did you pay the? You're gonna do one on the.
Let's say that.
Yes.
Yeah, but we see on
But right,
your FaceTime and every time.
it's kind of very ignored. I'm gonna call you when we're done, just have your parents' class.
All right.
Where's the-
Let's see, I'd say the odds of me coming to visit at any point are quite slim. But we'll see. I don't
Do you
know.
have a job lined up? You just kind of chilling.
Yeah, I have one. The same one. Well, I would just go back to the rest of my grade.
Ah. Do we have those 3 jobs yet?
Well, it's kind of like
Are you
I wanna-
looking for a job?
I want to work in food science. I do not want to go to grad school.
Food science.
Yeah. Want to be like a brewer or something.
Oh, really?
Yeah.
You should select different subject, like chemistry of molasses or.
Yeah, yeah.
You know, it's your destiny.
Before I joined Rasmussen's group, I was gonna do my senior seminar presentation on the chemistry of beer. But I think I'm just gonna do it on like my current research, like that I'm actually doing. But I have.
So what is the senior seminar basically just like next weekend?
Yeah, it's just paper and presentation. So the seniors, all they do, I can't remember how long it's supposed to be. But it's fairly short. It's like a, fairly short presentation about really anything that you want. It just has to be like, well, Hirschberger has to like improve it, but there's a why, you can do whatever.
So is it like something that you all work on the whole semester and then you all present at the end, or all like one person presents every week?
Yeah, it's like 1 or 2 people go every week. Whether that's like fair or not to have, like, there's volunteers, like you meet for the first week and then maybe there's, a couple weeks until somebody has like volunteered to present, and then every week, like 1 or 2 people go.
I think I'm first, so I don't have to do it anymore.
Yeah.
We had to do first speeches. Right?
Oh,
Again, I like volunteered.
In Seth's lab or like for my goals, my career goals. I mean, in the lab, we're doing like polymers now, but I don't know. I kind of just like my chemistry classes in high school. And I don't know, I was good at it back then, so. Yeah, I don't know. I'm not gonna be doing any sort of like crazy, research, like making new medicine or whatever. Like, yeah, I'm gonna make the best beer on this planet someday, for sure.
The best beer.
Yeah.
Is that gonna be our slogan?
So if you get famous off of that, does that mean that I can say I was friends with the famous beer?
I mean, that's not like, I'd be open to other things as well.
Yeah, remember us when you're famous and how we had separation anxiety.
For example,
Yeah, tell anecdotes when he's being interviewed, like, I remember when I was in undergrad, and
Weird.
I literally
Mm-hmm.
would also like kill for an offer that Evan had.
Evan, what was
Yeah,
that offer?
he was gonna be well, I wouldn't be in the same position as him because I don't have a doctorate, but he was gonna be a lab supervisor at Curaleaf if they legalized
Oh,
cannabis in Dakota. I mean, they didn't, so.
It's right there.
It's-
I voted yes.
He doesn't have an offer. Because they didn't legalize it, so they're not gonna, they can't do anything.
That's so
Yeah.
cool.
Yeah,
Yeah.
Evan Culver, offered to be like a lab supervisor.
And I voted yes on that head, but it's like
Yeah.
60 or no yes.
Which, yeah, the day going on improvements, so as well. I know it's only.
I know there were 2 states that.
No,
wanted to be-
utilize edibles, so.
Yeah, yeah.
I think one of them was my one.
Too bad we're all the way in.
Go to Minnesota, so we are not that close. I would never.
That's all, well, at least like concentrates and stuff, that's all like organic extractions, which are fun, so. That'd be kind of cool. That'd be more chemistry centric, I guess.
Oh, it was Maryland and Missouri.
Maryland and Missouri.
Yeah.
What?
I'm surprised by that one too. I think that's the first one. Yeah, yeah. It's perks of being a military kid with divorced parents.
Okay, yeah, I was unfortunately born in.
Ah.
That's like.
Oh, right.
That is. Nobody lives here. No.
Why do you want to then?
Because my dad was in the Air Force. Stationed in Grand Forks.
It's nice though. I like that.
Yeah. I don't-
It's much nicer than the one my dad used to do that. I was gonna say, why not? Yeah. It's so bad. So much space. Yeah. It's too nice there, but it's pretty good. I don't want to.
Yeah, he said that they would, like, he would go, they would on patrol all the time, like for the field or whatever. And the threshold, I think, was like -60 Fahrenheit for when they would stay out, because like that's the temperature that gasoline starts to congeal. So
I do this.
they literally.
That must have been very to deal with. You're one of those people that has to be outside of it.
Yeah, he did not have a good time, as far as I know. That's what he said.
Did he retire?
Yeah, he did his 4 years. He well, I don't know.
My dad's crazy. He just did 20 years and then he retired.
That's crazy. I don't know, honestly, I mean, there are not a lot of like career. Military men, there, and like in my family, at least, like there were a lot of people that were in it,
Yeah.
but only 40. There were some parents at the elementary school that I worked at that were, like, career long, like in the army or the navy or whatever, and they're like different, they got like a different.
Yeah. Yeah. I feel like a lot of people join the military because they just need something to get by, or they're still trying to figure out what they want to do with their lives.
Yeah, that is like how my dad was the guy to do it. He did it for like 1 year of school at first, and like wasn't, jiving with it or whatever. And so he went to the military and he hated it. Went back to school.
That's what happens to a lot of people. Here. Would you ever join the military?
No. Absolutely not. I would literally rather die. I'm
Fair.
serious, yeah.
Fair.
I mean, I'd almost rather die than,
Most things.
go to school. So,
Like, it's not difficult to persuade you that direction.
no, I would,
Those blankets that Jordan are just.
Yeah, at one point, it was not in place to occur, but close to in place.
my parents would never.
Oh, my parents like encouraged.
They were the ones, I remember in kindergarten, they like did this thing where they're like, no. It's like just a continuing thing, but like for the first time that I like remember in kindergarten, they did this thing, they're like, oh, what do you want to be when you grow up? And we had to like draw a poster or something. And I said I wanted to be like in the army or something because, like my dad and my grandparents and all these other people, like family members. And my parents were like, no, like they like were telling me that I did not want to do it. And yeah, they would not let me. They shy me away from it.
Now you're going into a much more respectable.
Yeah, I mean, I don't know,
Even the military is respectable.
Yeah, like joining the military here, no, but if I was in like Ukraine or somewhere, like that's fun.
yeah,
I mean, you might. Or
Horrible
most
that
likely will die.
Yeah, horrible that it's happening, but like that I would get so patriotic if that.
Yeah. Yeah.
But here, like I don't care about most people.
You have to like join the army of your own volition, though. You can't be drafted.
Yeah.
Because
Yeah,
otherwise.
then I don't care. That's like when someone tells me to do something I was not.
I think it's draft dodger.
Would you be one of those guys that like breaks your own legs and like, sorry, I should serve that
Oh
one?
my God. I hope it wouldn't come to that. I would just run away, honestly. I'd live in the woods or something.
I can see that.
I would.
Yeah. Would you go where the?
Yeah, for sure. I do that now. I don't like take care of myself up here. I just go to class, get my stuff done, that's all I need. Then when I go home to the rest of my life, I have to pay a little more attention. to things, but, yeah. But no, if I was in the woods by myself, do whatever I want, of course. As long as I was in like a good enough climate to like grow,
Yeah.
have my own garden.
AKA not North Dakota.
Yeah. Yeah, it's kind of been, I don't know if I'd say unfortunate, but
Someone who moved to North Dakota. Not because they were forced to, and not because their family lives here. Like, most of the people that I talk to, they are here because they either have family here, or this was just like the cheapest option.
I also like to came here, for like work reasons, which to me falls under that category.
Yeah.
I don't know, I mean, yeah, I guess there are
It's
some.
actually top four stage, like best places to live.
Is it?
In terms of like what you pay and like the level of education. Like enjoyment wise, I don't know. But like in adult terms, like what makes the most financial sense. Which isn't how I follow.
Yeah, that's because there, I don't even think there's a million people in there, so of course it's gonna be. cheaper.
I think-
There's not enough demand.
There are more people. There are like 200,000 more people in Milwaukee County than in North Dakota.
More people in.
Yeah, well, roughly, well, maybe like 170,
That's still a
Yeah.
lot,
yeah.
but how many cows though?
Probably more in Wisconsin than cows in Wisconsin.
Oh, yeah, but
It's more like agriculture, it's less.
yeah, that's true.
ranch.
How many?
All I'm saying is if you go to Aldi and you get a bag of potatoes, they're probably from Wisconsin.
Oh,
They've just been from Wisconsin lately, I don't know. They. Finally,
These are expensive these days though.
yeah.
My grandma was complaining about it.
It's a good thing your grandma, well, does your grandma try it? No. Explain her what-
Yeah, she just put gas in her own car though, and then talked to me about how it's important that women know those things. Like, man, you're 75 years old, I've known that for years. I put gas in my own car. My grandfather does that for her.
Yeah, there are a lot of cattle.
More cattle?
There are a million more cows than people in North Dakota.
Fair, bro.
There are, okay.
1,000 cows.
There are more cows, there are actually way more cows in Wisconsin, but there's like a lower ratio of like cows
Cows
to
to
people.
people.
You
Yeah,
guys
Yeah, what's the
know-
cow to person? Forget faculty to student. What's cow to person?
I know one, is that every one person on the earth, there's 1 million ants.
yeah. There are,
Male ants don't have faces.
the mass of like all the ants in the world, I'm pretty sure is like larger than the mass of all other like mammals and living creatures. Yeah.
Because there's so many of them.
Yeah.
What would you do if ants revolted against us? And y'all would fight off 1 million ants.
My brother stood in fire ants. We're like, don't stand there. Go to the right.
We would.
Alright, what is what's the scenario in which we're going up against 1 million ants? What is the location of this?
It's every person on earth, it's everywhere.
What?
There's 1 million ants for every person on earth.
So you
Every
can fight
person has to fight off their 1 million ants.
At one time?
Yeah.
I died.
It's all the ants are coming
Oh,
back.
It's like a one. I was actually gonna ask, do you want blue, orange, yellow, or silver?
Blue, yeah,
Like
bro,
baby blue?
yeah.
I actually.
I honestly would, we'll see. $30.
What's the range?
That's a good question. I would assume
Gonna need
like
some mild
I
radius. It needs to be in through smelling.
Yeah.
Maybe
Our
not.
one,
Not. That's probably less, that's.
That's why I need so.
Is that actually what we need?
yeah, no, 3 through 4. That's cozy the other day.
What?
Why?
For what? Yeah, oh, what was he chosen for?
No, it's.
Oh, yeah.
Show the light.
Can you go to plan?
I mean, that's my car though. That actually is way further away than I thought it was.
You guys watch Family Feud? I love when the like, watch Family is on their.
That's in cities. I think that this is.
I love when they say something so dumb that's clearly.
But this is 3 miles. This is like in a dense.
Fair.
Like if you have no. Yeah, yeah. So, yeah.
I do like that. But
And one thing you want your wife to do your face.
What's your way, home?
I love it.
Open it like in YouTube, but I guess not. Open TikTok.
There's one thing you would not want to walk in on if you were Robin Hood.
Have a seat. Oh. Yeah, but that's made of, you know.
I don't want to sit on it, have a seat. Yeah.
Oh my God.
New York Post.
Who says that? Have a seat. All good, right?
Can you imagine that would be someone who's like horrible to the point of it being annoying.
Yeah, like too much.
Yeah.
Relax a little. If someone said having seats. I feel like I'm going.
I'm gonna go with that. That's the same one I would say my lady.
Oh, but
They-
I like the way she tells other women.
Yes.
But I never actually like need it.
Yeah.
In ruin.
All,
I got something for, you know, little something.
What is it? We could just mention also. Maybe.
I did it.
To. Right now. Emma, I will get leaving,
I leaving?
or you have a few seconds more.
I have a few seconds.
Thank you so much. You have something to do. So,
Do you have a
please,
question for me?
Patricia, this question.
Okay. Oh. Is she changing the same things as I did to teacher? It's P not. P not X and P not Y. 27 or 27. So right now they're -50, so you can just change them to other values and see how it.
So am I able to do anything for Dr. Fox?
Yes. Just run the code that you already have. And, check what you then, modify. If you, at least in the, without any modification, run, report anything that you see, and make sure that you know how to.
Oh my gosh, I just realized how many vanity on your shirt. Goodness.
Stop going on.
Mhm. So we are not going to intellectual activity here. We need to get hands-on experience to feel how to respond to our manipulation. So do it like maybe a dozen times when people need to conditions for voice curve and see what that.
Very.
You will get your personal experience. If you change them dramatically, the movie will change dramatically. You change them a little bit, you can use EP, you know, control and modify the motion. We just asked Alicia about what code you use.
How do you generate movies and what do you do with that? But they automatically go.
And what do you do with them?
I sense it.
I think show. Show how.
So you want us to send these the different versions of it?
And record it was.
Yeah.
You can just, you know, collect links to several views in your report. It was, you, the immediately all the word provisionary all the data and it's not possible to speak. You inform rules and several videos sometimes press the one snapshots and show them the figure, the snapshots and stages. Let's just play with it and develop hands-on experience and then we'll go to analyzing more.
I got it, sounds good.
Because you know, a big hurdle for me. What if I change the initial position by one? Or whatever it is? If I take it next, this people do so much more time. Sometimes it makes sense less. It's nothing or fringes will pop up immediately. So I can express it well. You gotta try it several times and get experience how the model was all just to human thinking with language. My plans for the day are done. But if anyone has questions, I will be taking yours. Which one you
Going once.
you are doing your
So, could I just do it with kerosene? You don't see much with kerosene, it's just right in the middle. What is that?
So, what color is it? What color is it? How we put the rating on that?
Wait, so are we talking about like what I did in my presentation?
Oh, no. Remember, I studied once, what in class. He really did that as we did it as a cooperative team.
And like,
But
you did on the board, right?
so biology, many mystic can draw structures where there's PowerPoint and then
Oh,
Right.
yes.
if you do the same on the or ask
We're thinking of 3D model.
experiment for the person, so you can also send the reference.